Hello everyone, we're Kevin Aroca, Michael Bolivar, Luis Baute, Kareli Araujo, and Daniel Lázaro, and today we'll present the second order reliability method, also known as SORM. In general, we often deal with uncertainty, materials load, and consideration are not always predictable. Reliability methods help us estimate how likely and structure or system is to fail. The first order or reliability method or form provides a basic linear way to estimate this probability. But when systems behave non-linearly, we need a more precise approach. That's where some comes in. In the presentation, we'll explain what SORM is, how it works, and how it's priced and in general design.
I'm going to explain this part of the topic corresponds to my college careers. We can do it due to a health problem. The SORM method stands for the second order reliability method. It's an advanced approach used to calculate the fair probability of a system more accurately than for, while for approximate the feature surface a straight place, SORM use a curved quadratic surface to represent it. This allows it to capture nonlinear behavior. In real systems, mathematic SORM reflects the reliability index by considering the curvatures of the limit state surface. The general equation is, you can see the equation in the diapositive. These corrections give some higher accuracy when the limit state is not affected or when multiple variabilities interact in complex ways.
Now let's see how the SORM method actually works. The process can be summarized in four main steps. 1. Transform the random variables into the standard normal space. 2. Find the most probable point on failure. This is the point closest to the origin that satisfies the failure condition. 3. Calculate the principal curvatures on the limit state surface and the point. 4. Estimate the failure probability using the SORM formula, which corrects the result obtained by form. SORM method procedures transformation to use space random variables and transform it into the standard normal. Variables in space identification of the MVP, the most probable decision point satisfies the failure's condition is found. Calculation of curvature, principal curvatures of the limit state surface and the MPP are evaluated estimation of piece F. The second order approximation formula is applied to obtain the probability of failures. Conceptual visualization of the method. For approximation, tangent plane, and the failure point. Providing and simply and key to calculate linear approximation. SORM approximation curved surface than the fit actual. Limit state more precisely capturing. The nonlinear geometry, the set point, MPP, critical location where both methods evaluate the surface, the point close to origin in U. The image shows how the actual failure surface is better approximated by SORM than by force. Tangent plane, especially when there is significant curvature in the limit state.
SORM as a wide range of application across engineering fields. In civil engineering, it's used for a bridge, buildings, and dams. In aerospace, to evaluate the durability of critical components, and in mechanical design, to optimize based on reliability, and even in an electrical system for analyzing complex networks. Some of these advantages include a higher accuracy at the form, ability to molder at nonlinear limit states, a good balance between computational cost and precision. However, it's also limitations. It's more complex to implement, as it requires curvature calculation. It can be sensitive to the chosen design point. It's very precision system.
To finish, let us do simple example. Imagine structure where resistencia analog random variables. The limit state function is g r x q. X igual a R menos Q. In conclusion, the second order reliability method is as powerful evaluate the reliability of nonlinear systems. Thank you very for your attention.